Welcome back to the deep dive. Today, we're not just, dipping our toes into AI agents.
No.
We are going straight to the architectural drawing board. We're looking at what I think is really the highest level of agent engineering being deployed right now.
That's a good way to put it.
So if you've been wondering what it takes to build an AI system that doesn't just read text, but also, sees images, hears audio, and applies some pretty sophisticated reasoning across all of it.
Then this is the deep dive for you.
Exactly.
That's absolutely right. We are peeling back the curtain on 3 very specific, complete, ready-to-build projects.
And these aren't just toys, right? These aren't concepts.
Not at all. These aren't theoretical concepts built in a lab. They are end-to-end functional agents that are solving complex real-world problems right now.
Okay.
They really represent the frontier of what we call multimodality, this seamless combination of vision, optical character recognition, or OCR, audio, and critically, the structured reasoning that connects all these different inputs.
The sources we're drawing from today are, well, they're essentially the blueprints for these.
They are.
They lay out every single tool, every step of the workflow. It's almost like getting a definitive shortcut to understanding next-generation automation.
I think the significance here is enormous because these agents are complete solutions. They're designed for, production environments.
So they're robust.
They have to be. They take messy, chaotic, real-world inputs, like a shaky phone photo of a contract, a noisy lecture hall recording, a complicated website screenshot, and they deliver these highly structured, actionable, and importantly, templated outputs.
Right.
They really show how to bridge that gap between abstract AI capabilities and, practical industrial use cases where quality and reliability matter most.
Okay, let's unpack this core concept then. Multimodal. We should probably define that first because it's the foundation for everything we're about to discuss.
Good idea.
When we talk about AI, I think most people's minds immediately go to large language models, LLMs, handling text. But these agents, they go way beyond that single modality.
They do. Multimodality just means they process inputs from different sensory channels at the same time, much like a human brain does.
Okay.
They don't just wait for text. They ingest visual data, a photo, a dashboard, or audio data, a voice memo, a podcast recording, and then use a structured reasoning core to make sense of all that combined information.
Can you give me an example?
Of course. So an agent analyzing a legal document, for instance. It uses vision to assess the page layout, it uses OCR to extract the characters, and then it uses the LLM's reasoning to structure that raw text into legal concepts.
Like clauses, issues, precedents.
Exactly. It's that integrated workflow that really defines the agent.
And today we're looking at 3 very different applications: legal, media, and design QA.
That's right.
Which really shows just how versatile this architecture is. So our mission here is to break down the specific tools and the step-by-step workflows for each one and really focus on the technical why behind the choices.
Let's do it.
Let's jump straight into the first one, which tackles, I think, one of the most documentation-heavy industries there is. So our first agent, the legal document camera agent, this one feels, immediately transformative. Especially for any profession that's just buried under stacks of physical paper.
It is.
It turns a chaotic snapshot into a legal brief.
Its core purpose is remarkably focused, yet it's incredibly powerful. It's designed to convert a simple photograph.
Just from a smartphone.
Exactly. Taken by a smartphone of a physical legal document into text that is immediately structured and analyzable by a large language model.
Wow.
Just think about the pure speed increase for anyone dealing with, high volumes of archived or sensitive physical files.
I'm already thinking about who specifically benefits from this. Who are the target users here?
Well, the target users really span the entire legal ecosystem.
Okay.
The sources we looked at highlight advocates who need rapid analysis in the field, judges comparing documents right there on the bench, court clerks who are processing just huge volumes of intake.
And I imagine researchers, students.
Absolutely. Academic researchers, law students.
Right.
But crucially, the goal isn't just to transcribe text file. That's the simple part.
Right.
The agent aims for very specific output goals. Automatic clause extraction, identifying specific issues within seconds, comparing the document against, say, a known template or a previous court order, and then generating immediate structured summaries.
So that functionality goes way beyond simple character recognition. You're applying actual legal intelligence on top of the raw visual data.
That's the key.
Okay, let's unpack the tool set. Because this is multimodal, we're going to need specialized software for each sensory input, right?
We absolutely do. So we start with the image processing layer. For optical character recognition, the OCR part.
That's turning the picture into text.
Right. The process of turning the image into raw digital text. For that, you can use highly effective and, importantly, free open-source tools. Things like Paddle OCR or Tesseract.
Okay, I've heard of Tesseract.
They're the workhorses for character extraction. Really solid.
Now, here's where I want to dive a little deeper into the technical side. The sources prominently mention OpenCV right alongside those OCR tools.
Me too.
But if Tesseract is the thing extracting the text, why is a specialized computer vision library like OpenCV so essential? What's the technical challenge it's solving?
That is the difference between a system that fails, say, 50% of the time, and a professional-grade agent that is highly reliable.
Okay.
The thing is, real-world photos are almost never perfect.
Right. They're blurry. They're taken at an angle.
Exactly. You capture them quickly, often at an angle which leads to shadows, uneven lighting, maybe a glare from the overhead light, skewed angles. OpenCV handles the critical pre-processing steps that are needed to standardize this input.
Can you give me a specific example of that pre-processing? What does that actually look like?
Certainly. So if you take a picture of a document at a sharp angle, the text lines are skewed, right? That's a perspective error. OpenCV can perform what are called affine transformations. It's a mathematical process, basically, that detects the four corners of the document in the 2D image and then maps them back to a perfect rectangle.
So it's like digitally flattening the page?
Precisely. Yeah. It also handles something called binarization, which is just turning the grayscale image into pure black and white to dramatically increase the contrast. And, of course, noise reduction, removing that visual salt and pepper from poorly lit areas.
So if you skip that OpenCV step, the OCR tool might misread a C as an O or just miss entire lines of text because there was a shadow or a weird perspective warp.
100%. The quality of the reasoning core, the LLM, depends entirely on that clean, standardized input from OpenCV.
Garbage in, garbage out.
It's the oldest rule in computing.
Yeah.
OpenCV ensures the text stream going to the LLM is as reliable as humanly possible, no matter how bad the original phone picture was.
Got it. Okay, so once we have that reliably clean text, we move to the brain of the operation, the reasoning core.
That's handled by a robust LLM, something like ChatGPT, specifically leveraging its file search and advanced reasoning capabilities to apply that legal structure.
So it's not just any model.
No, the LLM here needs to be trained to understand legal syntax and, the semantic relationships in that kind of text.
And then for the final output, the polished document.
For generating the polished long-form output, like a lengthy legal summary or a complex draft argument that needs consistent formatting, the system uses a specialized tool. The sources mentioned Canmore.
We've seen Canmore pop up across a few of these high-end agent projects. What is it exactly, and why is it preferred for the final professional output instead of just, having ChatGPT format a summary?
That's a key distinction for building professional-grade agents. Canmore is a specialized long-form drafting and reporting tool.
Okay.
So while ChatGPT is excellent at unstructured conversation and reasoning, Canmore provides the necessary professional structure and template adherence.
Right, because legal documents have to look a certain way.
Exactly. In a legal context, your output has to conform to specific PDF formats, citation styles, or predefined tables. Canmore ensures that the reasoning output from the LLM gets transformed into a consistent, compliant, and maybe even branded deliverable. It maintains the high standard that a court or a law firm would require.
It removes the variability.
It removes the variability that's inherent in raw LLM output. You get the same professional format every single time.
That makes a ton of sense. Consistency is non-negotiable there. Okay, let's walk through the exact workflow then. The 5 steps that turn a quick phone photo into a structured legal brief.
Step 1 is the most straightforward. Capture the image. This is your input. A photo of a writ petition, a formal court order, a complex agreement, a government notification.
Even something like a receipt or an invoice for an audit.
Yes, absolutely. Anything with structured text on it.
Okay, so then step 2 is the OCR processing. That's where Tesseract or Paddle OCR churns through the image to pull out the raw character.
And then it goes immediately into step 3, which we've discussed, image pre-processing using OpenCV.
The quality control step.
Right. Standardizing the input through noise reduction, perspective correction. This is the foundation that all the subsequent intelligence rests on.
Now for the intelligence step 4, the ChatGPT analysis, or as the source calls it, the core intelligence. You mentioned it goes way beyond just summarizing.
It does.
What specific high-value tasks is the LLM performing here that justifies building this expensive specialized agent?
This is where the agent goes from being a technician to an analyst. Yes, it generates a full summary. It identifies the key issues. It extracts the relevant clauses. But the most advanced function is something called contradiction spotting.
Contradiction spotting.
Yes, it means identifying where two clauses within the same document might conflict with each other, or even more powerfully, flagging conflicts between the document's contents and some external legal precedents or internal knowledge the agent was fed.
Using a reg framework.
Exactly, using retrieval augmented generation.
Contradiction spotting in a split second. I mean, that capability alone could save attorneys days of deep reading and cross-referencing.
For sure.
But let me challenge this a bit. Isn't relying on a centralized LLM like ChatGPT for critical, high-stakes legal analysis a massive liability risk?
That is the essential question, isn't it?
I mean, what controls are in place to ensure the accuracy you'd need for something like, say, a judge's comparison table?
That's a great point. The reliability isn't based purely on the LLM's imagination or, just thinking about it. It's based on very structured prompts and external verification checks.
How does that work?
For contradiction spotting, the agent typically breaks the document into its core semantic clauses. It then performs a high-dimensional comparison. It's basically embedding searches between clause A and clause B.
Okay.
If the semantic distance is 0, but the resulting text is logically divergent, for instance, stating two different jurisdiction dates, the agent flags it.
I see. So it's more mathematical than interpretive at that stage.
To an extent. And furthermore, these professional agents almost always include a confidence score for their finding.
Oh, that's crucial.
It is. It allows the human user, the advocate or the judge, to quickly review the flagged contradiction manually. The AI provides the speed, the human provides the final liability check.
That confidence scoring is everything. What else can the advanced reasoning core look for?
It also detects missing information. So if the document belongs to a specific type, let's say a standard patent application or a public notification that by law requires 5 specific disclosures.
Right.
The agent can compare the extracted text against that required template and flag any required sections that are absent or incomplete.
So it's applying a structured legal framework to the extracted text, not just summarizing it.
Precisely.
And finally, step 5, the final output. What does the user actually hold in their hand, digitally speaking, at the end of this?
They get the clean text, a prioritized list of key issues, the important paragraphs already extracted, a structured summary, and even suggested next steps. It moves the user from passive analysis to active guidance.
And the deliverables themselves are tailored for that professional environment.
Yes, like the comparison table you mentioned.
Right.
The agent delivers a clean PDF summary via Canmore, a bullet point legal brief ready to use, draft argument notes, and that highly valuable comparison table.
And if an attorney wanted to integrate that table into their case management system, are they stuck with a PDF, or is the underlying data exportable?
Oh, it has to be exportable to be truly useful in a professional workflow.
Good.
While Canmore delivers that professional PDF report, the agent ensures the comparison data, the key findings, dates, conflicting clauses, are also available in a standardized machine-readable format, something like JSON or CSV.
Which allows them to import it directly into their own system.
Exactly, into their case databases or internal auditing tools. It ensures continuity.
So this agent takes a chaotic, unstructured input, a photograph, and delivers military-grade structure and actionable insights, all within minutes.
It's the ultimate example of combining visual preprocessing with OpenCV, extraction with OCR, and advanced verifiable reasoning with a structured LLM to create really significant business value.
It's an indispensable tool in those high-stakes, documentation-heavy industries, truly. Okay, let's dramatically shift gears. We're moving from the solemnity of the courtroom to the much more dynamic environment of media production.
Big shift.
Our second agent focuses on creative automation and high-velocity content creation, the podcast pipeline agent.
This is a fascinating use case. It really focuses on transforming an unstructured, highly dynamic input, which is just human speech, in a raw audio file into a complete, ready-to-publish digital package.
It's an efficiency multiplier.
It is. It automates almost the entire post-production workflow.
And the outputs are incredibly comprehensive. I mean, it's a content creator's dream. We're talking about generating the full transcript,
Yep.
shaping that into an actual episode script, automatically drafting the title and description, generating SEO-ready hashtags, and even creating the thumbnail design concept.
And what's really compelling here is that this agent is proven in production.
It's not a theory.
No. The sources cite specific examples of entire podcast series that are powered by this workflow. Niche but popular shows like True Courtroom Stories, the philosophical and complex AI-era Islamic Abrahamic Wisdom.
The AIAW.
That's the one. And even the geopolitically focused Pakistan Zindabad, the next superpower.
So this proves its capability for sustained, high-quality, and linguistically complex long-form content.
Exactly. It works.
Let's delve into the specialized tool set then. We're mastering audio and visual components in this pipeline.
Okay, so the foundational tool for the audio input is Whisper for transcription.
An open source tool, right?
It is. And it's essential for converting that voice recording into reliable text, which then becomes the critical bridge between the audio input and the reasoning core.
Because without highly accurate text,
all the subsequent steps just fail.
Now, here's a crucial technical detail that the source material highlighted. Whisper's capability in multilingual transcription, specifically Urdu and English. Why is that capability so technically significant, especially for the markets those specific podcasts serve?
That capability addresses the real-world complexity of language use, specifically a phenomenon called code switching.
Code switching.
In many regions, particularly South Asia and parts of the Middle East, conversations frequently switch between native languages like Urdu and English, sometimes mid-sentence.
I've heard this a lot.
For standard single-language transcription models, this abrupt switch causes massive failures. You just get garbled text. Whisper is robust enough to accurately parse and label text in both languages seamlessly within a single audio file.
So that's what makes the Pakistan Zindabad or the AIAW podcasts actually possible without a human spending hours just cleaning up the transcript.
Precisely. The AI handles the linguistic complexity that's just inherent in those markets. It lowers the barrier to entry for multilingual content creation dramatically.
Once we have that reliable dual language text, the structural work begins.
Right, which is handled by ChatGPT combined with Canmore, correct?
Yes. ChatGPT performs the structural editing and the, creative adaptation, but it works alongside a structured tool like Canmore.
And what's the role of Canmore here?
Canmore ensures the resulting script is properly formatted, segmented with time codes, and professional. It meets broadcast standards rather than just producing a raw block of conversational text.
I see. And for the visuals, for the marketing assets.
For the thumbnails and episode art, the agent uses specialized image gen tools, or it can integrate with third-party platforms. The sources mention Canva or Leonardo.
And they generate the artwork based on what?
Based on semantic input that's derived from the episode's content itself.
Clever.
And finally, we need the glue, the automation.
Right. Specialized automation tools handle the publishing schedule. This includes things like setting weekly post reminders, scheduling YouTube uploads, managing social media posts.
And make sure the operational side of the series runs on Rails.
Pretty much.
Okay, let's walk through the 5 steps of this workflow, starting from just a raw voice file.
All right. Step 1 is the input audio. And the source material highlights just how diverse this input can be. It could be a formal, high-quality courtroom microphone recording.
For true courtroom stories.
Exactly. Or an academic lecture, a casual voice note you captured on your phone, or a structured interview.
And these inputs are often noisy, highly variable, which makes step 2 critical. Whisper transcription.
We covered its multilingual capability, but the speed and accuracy are also key here. The agent has to handle long-form audio files, sometimes hours long, and output an accurate text file that preserves speaker identity and timing markers.
Which is necessary for the next step.
Absolutely.
Once that accurate text, complete with timestamps, is generated, we hit step 3, ChatGPT script generation. Can you detail how ChatGPT acts as a creative editor here?
It essentially acts as the content editor and the segment producer. It's not just cleaning up the transcript, it's applying a storytelling structure. It takes that raw conversation and shapes it into a polished episode script. It often organizes it into distinct dialogue sections. It can identify segments where a formal storytelling narrator needs to provide context or a transition.
I see.
And it generates specific legal or academic explanations that might be required by the genre. And, crucially, It creates standardized, professional intro and outro segments to maintain that brand consistency.
So it's recognizing that raw speech needs to be translated into a broadcast artifact.
Precisely. It structures the narrative flow for an audience.
Then step 4 is visual creation.
Right, so while the script is being finalized, the agent is simultaneously using the core themes and topics it identified in the text to create the necessary marketing assets.
And how does the agent communicate what it needs visually to the image generation tool?
Well, the agent first summarizes the episode into, say, 3 to 5 key concepts. It identifies the tone. Is it serious, philosophical, political? And it extracts key phrases.
I see.
This semantic data is then passed as a highly specific, optimized prompt to the imaging tool.
And the tool Canva or Leonardo generates the thumbnail and other graphics.
Right. A compelling thumbnail, supplementary episode artwork, social teaser graphics. This ensures the visual theme aligns perfectly with the content theme, without a human designer needing to listen to the whole episode first.
And the final step, step 5, publishing automation gets the content out into the world.
Yep. It moves the content from creation to public distribution. And this ensures consistency, which, as you know, is the lifeblood of media.
Absolutely.
The agent manages the operational side. It uses API calls to set up scheduled uploads to YouTube. It queues up formatted posts for social media with the generated hashtags. It handles file conversions. The entire process, from a raw voice note to a scheduled public post, happens without manual intervention.
That's true content velocity.
It is.
So the resulting package is just comprehensive. The full script, engaging title, SEO-optimized description, hashtags, and the thumbnail concept.
And the applications for this go far beyond traditional podcasters. Think about university professors turning spontaneous lectures into structured online learning modules.
Or lawyers archiving and summarizing long arbitration proceedings.
Exactly. Any industry that relies on spoken communication for knowledge transfer gains immense professionalization and distribution capability from this single integrated agent.
It effectively removes all those tedious, time-consuming steps, the manual transcription, the formatting, the design briefing, and lets the creator just focus on the quality of what they're actually saying. Okay, let's move to our third and final agent. This one focuses on the intersection of design, technology, and quality assurance. This is the website Visual QA Agent.
This agent addresses a chronic and, frankly, expensive problem in digital product development.
Which is?
Manual QA. It's slow, it's subjective, and it is very prone to human error.
Right.
This agent's core job is to analyze screenshots of websites, applications, or mobile mockups to detect aesthetic and technical flaws that a human might miss or just find incredibly tedious to catalog.
And to do it instantly.
Instantly.
What specifically can this agent detect in just a screenshot?
It focuses on visual inconsistencies and structural failures. So this includes classic UI/UX issues, broken layouts, things like alignment errors, inconsistent spacing, missing elements.
Like a submit button that just didn't load.
Exactly that. A form submit button that didn't load. And just general design problems. It's an automated, hypervigilant quality tester for digital interfaces.
The target users seem pretty clear here. Freelance designers, web development agencies, SaaS entrepreneurs.
Anyone who needs instant, objective feedback on their digital property without waiting for a lengthy, expensive human audit.
Absolutely. Because time is the most expensive resource in software development.
For sure. This agent shortens that feedback loop from days or hours down to just seconds. It dramatically accelerates the iteration cycle.
Let's look at the tool set. This one seems pretty sophisticated, specifically because it relies on these advanced vision models. This agent needs more than simple OCR. It needs deep visual comprehension.
Precisely. This agent relies heavily on the ability to understand UI semantics. It actually starts with OpenCV again for initial image processing of the screenshot.
But its role is different here, right?
Very different. Here, its role is often segmentation identifying and isolating specific regions of interest, like a navigation bar or a footer, rather than doing perspective correction on a photo.
Then we hit the core intelligence, the vision core. Why does this task specifically demand the absolute latest models like GPT-4o Vision or Gemini Vision?
Because these models don't just register pixels. They understand the function of those pixels within the context of a user interface.
Okay, what does that mean?
They can recognize that a group of pixels represents a button or a modal window or a data visualization chart. And this is crucial for detecting semantic errors, like a missing call to action button or an incorrectly formatted error message. You need these state-of-the-art models to apply design heuristics and functional logic to a purely visual input.
So once the vision model has analyzed the image and tagged all those components, we still need that structured reasoning layer on top.
That's handled by ChatGPT. It takes the massive volume of raw visual findings. Object 14 is misaligned by 5 pixels. Color contrast ratio is 2.1 to 1, and processes them into actionable, structured data.
And then Canmore again for the final report.
Exactly. Canmore generates the final comprehensive professional audit report, ensuring the output is immediately presentable to a client or a development team.
Okay, let's dissect this workflow. The process is structured in 4 steps, which is interesting. The other 2 were 5.
Good catch.
Why the reduction? Does it inherently require less pre-processing?
That's a really insightful point. The reduction to 4 steps is justified because the input, a digital screenshot, is inherently cleaner than a physical photo or a raw audio file.
Of course.
We eliminate that complex pre-processing step that's necessary to correct for environmental chaos, shadows, skewed angles, audio noise. The input starts as clean 2D data, so the complexity is shifted entirely into the vision analysis step.
That makes sense. Less chaos going in, so the intelligence layer has to work harder. So Step 1 is just upload screenshot, landing page, app UI, a mobile app, mock-up, whatever.
Step 2 is where the magic happens. Vision analysis. The sources call it the AI's eye. This is where the core work is done. The model is trained to hunt down these really granular errors.
Like what?
It detects alignment errors by measuring pixel distances between elements against a known grid reference. It calculates color contrast ratios to ensure compliance with accessibility standards like WCAG.
How does it do that?
By identifying the foreground and background colors in specific regions and running the math. It's very precise.
And it detects structural issues, too.
Absolutely. It detects broken or overlapping components. It flags missing buttons or elements that are logically expected on that page type. And, very importantly for developers, it can detect non-responsive layout problems.
Ow!
By essentially simulating different screen sizes and identifying where elements fail or break their containment rules.
I can just imagine a designer uploading a complex prototype and getting a list of 50 potential flaws back in seconds.
Right.
But that list needs to be usable. How does the LLM turn that raw list into a professional audit?
That's step 3. ChatGPT reasoning and prioritization. And this is arguably the most critical step of the whole process. The raw findings from the vision model are just data points.
Right.
ChatGPT applies industry-standard UX heuristics and professional logic. It doesn't just list the flaws, it generates concrete UX suggestions. Specific accessibility improvements like increased button padding by 12 pixels for a better tap target size, and crucially, it handles error prioritization.
How does the AI determine that a missing navigation link is priority 1, but a subtle typo is, say, priority 3?
It applies a pre-programmed weighting based on the functional severity of the failure. A missing element that breaks navigation or prevents a transaction. That's a P1, a blocker. A violation of the WCAG contract requirement is a P2, a significant legal liability. A slight aesthetic misalignment might be a P3. This ensures the output is an actionable development plan, not just a list of criticisms about the design.
But wait a minute, can an AI really judge aesthetic quality? I mean, UX often relies on subjective factors, brand voice, emotional impact. Isn't that outside the scope of this kind of technical QA?
That's a powerful point, and it's where we have to differentiate QA from pure design feedback.
Okay.
The agent avoids subjective aesthetic judgments. It's not going to say, I don't like this color. Instead, it focuses on measurable, objective criteria. Alignment, consistency with known component libraries, contrast, performance indicators, responsiveness.
So it's not a replacement for a creative director?
Not at all.
Oh.
But it is an infallible replacement for a tedious human quality assurance team that's just checking boxes for technical compliance.
Understood. It focuses on the functional integrity. And the final step, step 4, is the report creation.
And using Canmore, the agent generates the final professional deliverables. This includes a full UX audit document, a clear table of prioritized issues, P1, P2, P3 recommended corrections mapped back to the specific component, and technical guidance on contrast and typography.
And that report can be handed directly to a lead developer or a client immediately.
The impact on business value here is immediate. It just accelerates quality testing so significantly.
It removes the largest bottleneck in the design to development cycle.
It does. Freelance designers can instantly validate their mockups, web dev agencies can automate pre-launch checks across hundreds of pages, and SaaS founders get that rapid, objective feedback they need. leveraging AI vision to enforce design and quality standards at machine speed and precision.
It's truly amazing to look back at these 3 projects and see the diversity of inputs they handle: a legal photo, a voice recording, a website screenshot, all relying on the same architectural principles.
The common thread across all three is that high-stakes synthesis of core data types. We saw vision in an OCR in the legal and QA agents,
We saw audio and video in the podcast agent.
and structured reasoning, linking everything together. Whether it's structuring legal clauses, generating multilingual scripts, or prioritizing design errors, that reasoning core is the ultimate orchestrator.
And I think we've really hammered home the point that professional-grade AI agents are defined not just by a single large language model, but by the meticulous workflow planning.
Yes, and the strategic combination of specialized, often free or open source tools.
Right.
That is the essential key takeaway from all the source material, and it's a revolutionary concept for the industry.
How so?
These systems, which represent the most advanced level of practical agent development, yielding incredible professional results, they are achievable without requiring deep learning coding.
That's a huge point.
It is. By mastering the integration of tools like ChatGPT, open-source multimodal stacks like Tesseract, Whisper, or OpenCV and orchestration tools like Canmore, the barrier to entry for building these immensely powerful, complex systems is significantly lowered.
So it means the ability to architect these advanced professional build systems is now accessible to a much wider audience of builders and innovators.
People who focus on workflow and integration, rather than purely on foundational model training.
It's the democratization of complexity.
It really is. You don't need a PhD in computer vision anymore to deploy an agent that can analyze a complex court order or automate an entire podcast series with multilingual content. You need an understanding of which specialized tool solves which specific problem in the workflow chain.
And that knowledge, which we've unpacked today, is the true power.
That's it.
What a profound change in the landscape of AI development. The intelligence is distributed, and the value is in the execution of the workflow. That concludes our deep dive into the construction of 3 highly advanced multimodal AI agents. We've covered everything from image processing for legal documents all the way to creating complete audio content pipelines.
The capabilities we've explored, converting this visual and audio chaos into prioritized, structured, and actionable data, they fundamentally change how knowledge workers operate across law, media, and tech development.
So as you go back to your own projects and reflect on the power of these integrated multimodal agents, here is a final thought to mull over.
Okay.
Given that structured reasoning agents can now process legal photos, multilingual audio lectures, and visual design screenshots automatically without any manual human intervention, what common, complex industry task do you now see as the next immediate and most obvious target for multimodal automation?
That's a great question.
Think of a process that right now still requires a human eye and a human ear simultaneously, but is just perfectly poised for the kind of end-to-end integration we just explored.
That's the fun of this new era, isn't it? Every manual process that requires multiple sensory inputs is now on the clock for efficient automation.
Thanks for diving deep with us. We'll see you next time.